All right, how's everybody doing today? Welcome to my channel, and I'm getting this going a little bit late today. Today's been one long emergency for me to tend to, and so this might be a little bit shorter video, but we're going to get something accomplished anyway. This is an educational channel, and we attempt to shed light on some of the great theories of everything from days gone by. And today is the 331st video that we have done on the reciprocal system of theory from Mr. Dewey B. Larson. Mr. Larson was an engineer that lived in the 20th century and died in 1990. From 1930 to 1990, he worked out his reciprocal system, the first half of which he was pretty much using a process of induction to take his initial epiphanies and turn them into his two fundamental postulates that summed up his reciprocal system. And then the next 30 years he spent writing books, taking his two postulates and turning them into a theoretical universe from which he wrote many books and many articles that are, some of them are, I think, quite fantastic in his ability to probe into any subject, physics and chemistry and astronomy and economics, biology and philosophy and religion and psychology. And the basic, his two fundamental postulates, the first one is the most important, and it is basically that the universe is not made out of matter, and the universe is not made out of energy either, but the universe is made out of motion. And in particular, the universe is made out of 3 dimensions of discrete units of scalar motion. Now, what that basically means is that, and then that motion is the relationship between space and time. And so what that basically means is that space and time are reciprocals of one another. They do not exist in and of themselves, but they only exist together in motion. And motion is more or less a fraction with time or space as the numerator and space or time as the denominator. And space and time come only in discrete units, meaning that they are quantized. There is a minimum unit of space and a minimum unit of time. If you don't have a full unit, then you ain't got nothing. And if you have exactly 1 unit of space in 1 unit of time, you have the speed of light, which Larson refers to as unit speed. And unit speed is basically the background of the reciprocal system universe. And so half the universe is moving faster than the speed of light, which is blasphemy to the orthodox scientists out there who follow Einstein, who said that the speed of light is the maximum speed of the universe. For Larson, the speed of light is the midpoint of the universe, or the null point, the state of rest, the origin, the 0 point, the ether of the universe. And half the universe is moving faster than the speed of light. Half of which Larson refers to as the cosmic sector. Half the universe is moving slower than the speed of light, which Larson refers to as the material sector. And the material sector is the half of the universe that the scientists are familiar with, and where they make their observations and measurements. And but fortunately, the cosmic sector is a reciprocal of the material sector, and so you can understand through extrapolation what's going on in the cosmic sector simply by inverting the roles of space and time when you cross over that border. And you can kind of see what I mean once you understand that space and time both have their coordinate aspects. 3 dimensions of space, XYZ coordinates, and 3 dimensions of time, which is an unfamiliar concept. And that is called coordinate time. But then space and time also have their scalar, or what Larson calls their clock aspects. Clock time. The clock is always getting later and later and later and later. And but not in any particular direction. And clock space, which is an unfamiliar concept, but basically space is getting farther and farther and farther apart. And this was actually observed by the Hubble telescope, which observed that all of the distant galaxies are moving away from each other. And it also can be envisioned using a balloon with dots on it. You blow up the balloon, all the dots are moving away from each other. That's basically clock space, or the progression of space, or the flow of space. So if you're in the material sector, you're dealing with a world that we're familiar with, a world of 3 dimensions of space and clock time. The clock's always getting later and later and later. But then if you cross over to the cosmic sector, you're dealing with 3 dimensions of time, coordinate time, and clock space. Space is always getting farther and farther and farther apart. So you can see that in the cosmic sector, you can understand the cosmic sector by simply inverting the roles of space and time from what you see the relationships are in the material sector. Okay, now today, with that fairly quick summary, hopefully we might be able to flesh it out here a little bit. Today is the second episode of going through Larson's article called "The Search for the Ultimate," and so if you want to get the first half of this paper, watch yesterday's video, and then so today hopefully we'll be able to wrap up this article, "The Search for the Ultimate," and in the beginning of the article, he just talks about how, the scientists of the past had their various debates about what the universe is made out of. It went from the 4 elements, earth, air, fire, and water, and the Chinese had fire, water, metal, wood, and earth. And then the Greeks kind of came around and they had the atom, so the universe of matter. And then some other people came around and they proposed the universe of energy. But then there were several scientists in the past who proposed a universe of motion. But they couldn't get their theory off the ground because they didn't have a good definition of motion. So that's where Larson sets himself apart from them, is that Larson defined motion as the relationship between space and time. And so I'm guessing that in the second half of this article, he maybe fleshes out some of this here. We'll read the last few sentences of the previous and then move on. Indeed, none of them really got off to a good start. These are the motion people. None of them really got off to a good start, but the complete failure of the present-day concept of a universe of matter to meet the tests of validity makes it imperative to continue the efforts along this line of a universe of motion and call for a more critical examination of the obstacles that have hitherto prevented taking advantage of the potential that is inherent in the concept of a universe of motion. This is the background of the research on physical fundamentals that I and my associates have undertaken and on which we have spent a great many years. In essence, what we have done is to locate the error that has stood in the way of developing a viable theory of a universe of motion. This error, we now find, is at the very base of the currently accepted theoretical structure. A mistake has been made in the definition of motion, one that excludes most of the basic motions of the physical universe. The prevailing view is that every motion is characterized by a magnitude and a direction, and can therefore be represented by a vector in a spatial coordinate system. Like the assumption as to the fundamental status of force, this definition of motion persists only because no one has questioned it. As soon as the issue as to its validity is raised, it can easily be seen that the definition is much too restrictive. There are observable motions that have no inherent direction. For instance, all of the distant galaxies are observed to be moving away from our location at high speeds. Unless we make the assumption that our galaxy is the only stationary object in the universe, an assumption that was repudiated by science long ago, this means that we are also moving outward away from all of the other galaxies. That is, we are moving outward in all directions. And since it is conceded that our galaxy is not unique, it follows that all galaxies are moving outward in all directions. If these were ordinary vectorial motions, the only kind of motions currently recognized by science, the motions in all directions would cancel out, and there would be no actual change in the position of any galaxy. But the measurements of the Doppler shift in the frequency of the radiation that is being received from the galaxies shows that they are actually receding from us, and therefore from each other. Such a motion in all directions has no specific direction. It is a scalar motion, one that has no property other than a positive magnitude, represented as an outward movement in the reference system. We encounter the same kind of motion in gravitation. If we visualize a group of gravitating objects scattered in space and far distant from any other aggregate of matter, we know from Newton's discovery that each of these objects is moving toward all the others. In this particular case, then, gravitation is also a scalar motion, not merely the equivalent of a motion, as asserted by Einstein. The gravitational motion of these objects differs from the motion of the galaxies only in that it is negative, inward in the reference system, whereas the galactic motion is positive, outward in the reference system. So that gravitational motion would be like taking that balloon with dots on it and sucking it in instead of blowing it up. You suck it in and all of the dots are moving toward each other. And that is a la gravitational motion, an inward scalar motion. This brings up the question as to the nature and function of the reference system. We are accustomed to identifying motion by change of position relative to some identifiable objects that we regard as motionless in ordinary practice. The surface of the earth and those objects that are motionless relative to the Earth's surface are the reference objects. For scientific purposes, we recognize that these objects define a reference system to which we can relate the various motions for mathematical treatment. On the basis of the prevailing definition, both the magnitude and the direction of motion are specifically related to the coordinates of the reference system and are independent of the location from which they are being observed. If object X is seen to be moving due north when viewed from point A, it is also seen to be moving due north when viewed from any other point B, providing that the observations are accurate in both cases. But, as we have just seen, this is not true in the case of scalar motion. The direction of a scalar motion depends entirely on the location of the reference point. In the galactic case, if we designate our galaxy as A, the direction of movement of galaxy X, as we see it, is AX. But observers in galaxy B, if there are any, see galaxy X as moving in the very different direction BX. Those in galaxy C see the direction as CX, and so on. In the galactic case, the location of the observer is the reference point, but in the more general situation, the reference point is determined by other considerations. For instance, the motions of spots on the surface of an expanding balloon constitute a scalar system of motions for which the reference point is the point on the balloon that is in contact with the surface on which the balloon is resting. In a gravitational system, the reference point is usually determined by the location of the largest object in the system, which is immobilized by its own inertia. We thus can see the identification of gravitation as a scalar motion is not confined to those cases where the gravitating objects are free to move in the reference system. All particles and aggregates of matter are moving gravitationally, irrespective of whether or not they change position in the context of the spatial reference system. Observations show that the magnitude of the gravitational motion is a measure of the amount of matter, that is, the mass. From a theoretical standpoint, the mass is usually identified with the inertia, but the inertial mass and the gravitational mass are numerically equal, which indicates that they are merely two different aspects of the same thing. The finding that gravitation is a motion explains this identity. Gravitation is the motion itself. Inertia is the resistance that this motion offers to an opposing motion. Matter, then, is a form of motion, as so many investigators have long believed. Furthermore, when the gravitational force is identified as the force aspect of a scalar motion, it can be seen that the forces due to the electric charge and its magnetic counterpart have the same general characteristics as the gravitational force, the characteristics of scalar motion. It follows that these forces, too, are properties of hitherto unrecognized scalar motions. Thus, recognition of the existence of scalar motion unites matter and the forces that act on matter. All physical entities and phenomena are motions, combinations of motions, or relations between motions. The universe in which we live is a universe of motion. Okay, that is the end of the article, The Search for the Ultimate, by Dewey B. Larson, author of The Reciprocal System of Theory. And that's one thing I didn't mention at the beginning. I was saying that, the ancients, use the 4 or 5 elements as the ultimate the ultimate thing that the universe is built upon. And then the Greeks came along with the matter concept, atoms, and Einstein and his crew had some of them thought that it was energy, but then there was also force. And that's, he talked about how Einstein spent the last 20 years of his life searching for the unified field, the unified force field, unifying all of the forces, gravity, electricity, magnetism, the weak nuclear force, which is, just a made up fudge factor for their own ignorance, and same with the strong nuclear force. And Einstein felt that all of these forces would somehow be able to be unified. And Larson's basically just saying they're barking up the wrong tree, because force is not the ultimate thing on which the universe is based. It's motion, and force is just a kind of motion. In the reciprocal system, all motions have space or time coordinates. So speed is space over time. Acceleration is space over time squared. Force is the conjugate of that, time over space squared. Energy is time over space. Matter is time to the third power over space to the third power. Inertia, gravitation, space to the third power over time to the third power. Pressure is time over space to the fourth power. Capacitance is space to the third power over time. Resistance is, I think, time to the second power over space to the third power. And on and on and on. So that's kind of how it works. I hope this was somewhat enlightening to some people. And we will be back with another article tomorrow. Thanks for tuning in. Have a great day.